welcome everyone to this episode of Passive House Accelerator Live. Today is a construction tech episode, and we have Mark Willie, Kevin Brennan, and Sean St. Amour here as our co-hosts for the episode. We're really excited to have Alex Giblin here from Geologic speaking about offsite construction and DfMA. This is where we explore how to slash the greenhouse gas emissions from our missions and make us more resilient to the impacts of climate change. And in the month of November, we're exploring the impact that prefab can have on that mission. So with that, I will hand it off.
Well, thank you, Zach. And I always love the intro. We are set, DfMA. If you haven't heard that term before, that's why you're here. If you have, we're going to dive even deeper. My name is Mark Willie. Thrilled to have you and your colleagues listening over your shoulders here on Construction Tech. Today, I ask that when you have questions, you please put them in the chat. We will get to them after the presentation. Please, whether it's simple, put it in there. And if it's a lengthy one, also put it in there. You might find that folks throughout the presentation are answering that. So please just be yourself. We will meet you where you are. And please, again, turn your cameras on, your microphones off, get dialed in. And now over to you, Sean.
All right, my friend. Well, I'm somewhere with a PH. I'm in Philadelphia for Greenville, and our other co-hosts, Ilka and Shannon, are somewhere down there hanging out with all of other friends that are here part of with Fias. They've got a great corner. A lot of other suppliers, manufacturers that we rely on in the Passive House movement are here in Philly. So glad to be here, glad to explore, collaborate with all of our friends. And we'll also be hanging out with some other friends, the B Public Prefab and 475 for a little celebration. So full day here in Philly. But first, we're here for Construction Tech Passive House Accelerator Live. Kevin, over to you, bud.
Thanks, Sean. I'm Kevin Brennan with Brennan Insulation and Airtightness. I'm here in New York City and proud host of Construction Tech, where we're going to get a little bit technical. We're going to get into the T's. I'm happy to introduce our speaker for this afternoon. Alex Giblin is a carpenter with over 20 years of field experience. In the past couple of years, he has taken a deep dive into CAD and BIM tools in an effort to improve construction plan details and develop processes that yield improved coordination between various parties involved. Delivering architectural AEC projects, his work at Geologic is currently focused on CAD modeling and the development and implementation of BIM schemes to improve upstream DfMA processes. He is an advocate for advanced and proliferation of free and open source standards and working methods for increasing interoperability with the AEC sector. Recently, he has been working to extend ICF schema industrial foundation classes to describe panelized buildings, assemblies, and is experimenting with new workflows utilizing open source tools. It's going to be a great show. I am excited to have somebody from Geologic here. They've been a leader in the passive house world for quite a few years, and I'm excited to see what they are presenting and Alex has been working on. So the floor is yours, Alex. Thank you.
Thank you, Sean, Kevin, Mark, Zach, Kim. I think I got everybody. I'm happy to be here today talking about DfMA, designed for manufacturing assembly. We also throw a L in there sometimes, logistics, as trucking is a key component to delivering offsite panelized construction projects. I'm going to start a little about me. I'm a carpenter, as mentioned, for a long time. I've been working at Geologic for coming up on 4 years now. I've spent the first 2 years out in the field. Here's a map of Maine. We have 2 shops at Geologic. Our main facility is in Belfast. That's the upper one there. And then another one down in Scarborough. Those yellow circles are kind of site are where we will like fully GC a job. So in the past, as we've transitioned to more panelized assemblies, we've done a lot of site builds. And that's what I got hired doing when I started 4 years ago. Here's an example on our houses. We're building, delivering passive house. We're using Windows, high performance Windows from Germany. We have a 14-inch wall right now. That includes a strapping layer. And we deliver projects all throughout New England. Here's our new shop. We opened this last May. It's in Belfast, Maine. We built it ourselves. We panelized it on site and stood them up, balloon frame, and put trusses on it. Here's a bunch of projects all throughout New England, and we do go out of state quite a bit. So here's a couple years ago, me site building, my first build with Geologic. I'm just going to talk a little bit about site build as set the stage for the comparison to fully modeling things in advance. Yeah, working cold outdoors. Here we are framing in January, setting trusses, windy, cold. And we're always working just from plans. This is kind of like proto DfMA for me. I always would make my own framing plans, and I would draw them out and figure out how to build things beforehand. A lot of times nobody could read them but me, but it was a good way to plan for my builds. I started doing some programming even years ago. This is sort of evolved from the TI 89 calculator use in high school. So like making cut lists, I could generate things under a roof slope, studs, some framing, just again, I have the background, so I was well suited to be digging into CAD modeling and advancing these techniques. So I never built with panels in the first couple of years. I was really curious, how the heck was it done? We have all these trailers. We're shipping buildings out of state, cross state lines. We have overpasses, height requirements, and go all over New England. And there's our first parameter for constraint, right? Height and width. We have to ship these at a road legal height. We typically try to avoid oversized load designation, just to simplify on our end. So I was seeing these shop drawings that were made in the shop. Again, I was not familiar much with panelization. And we were working from the shop drawings, building panels on tables. And then there was this 3D model thing I kept seeing. I was very curious about it. How was this being done? How were we taking plans, like I was familiar with working with, and translating them to build when we're building in the shop? How was it done? I asked a lot of questions. The guy who is now retired, who had my job before me, was just a classic, a really good architectural technologist, been in the industry for 40 years. And he took me on as an apprentice a couple years ago after a lot of pestering. So here's what I inherited was his process, which worked well, but was not without complication, which I'll explain. We were taking the sections and exporting as DWG, DXF, vector art, and bringing them into the 3D program. We use a program called CADWork. It's a very powerful modeler, has parametric tools for discrete element framing geometry. It's a good, solid modeling program. So we bring in the successive plans, right, along the Z, and then we'd bring in all the sections, and we'd build this framework, this skeleton from the plans. And then we would create these rough volumes. And then from the rough volumes, we were able to generate walls. We're placing all the windows manually and things as per the plans and sections and elevations. And then we can parametrically generate all of the framing geometry, the entire assembly. So parametric generation, this is a really cool thing. We use this tool called CADWork. It has its roots in Switzerland, I believe. I think it goes back to the early 80s and like watch making, just really technical drafting. But it's evolved for the timber industry and is used a lot in Europe and increasingly in North America. It has this thing called the element modules for parametric definitions of wall framing geometry. So take, for example, here's a wall, and I'll just highlight a single stud here. Well, you set with this graphical user interface just through checkboxes, a whole bunch of, I want it to stretch with the top of my rough volume. I want it to distribute at a certain interval. I want it to have a cutting priority. I'm showing this here because I'm interested. I hope people will revisit this, take a screen grab. This is something we want to reverse engineer and make more tools like this. It's very, very cool. So we have our rough window and volume set, and we're ready for discrete element. I hold Alt E, run the element module, and poof, I get a whole house, just like that. Seems easy, right? There's a lot that goes into it. I'm going to talk about the historical process and some of the complications that arose, and then some improvements that I've been looking at. Okay. So really this whole thing, designed for manufacturing and assembly, the basic idea behind it all is what you identify constraints and limitations downstream of the design process, whether it be installing or shipping or ease of assembly, safety, all these things come into consideration. And then, so let's take, for example, shipping constraints. That informs my panel heights. I can't build a wall panel unless I'm going to side ship something, which increases complication. So I have a height right there that I have to conform to. We have a saw at our new facility that we got. It's a linear processor. It takes output from CAD work and produces cut files, and we are able to, it's essentially a CNC saw, but very primitive. It's just linearly cutting, and here's the range of motion it has. So there's a bunch of parameters that I have to work with. I don't want to be designing things that I can't cut here. Here's something of the simple text file that it works. So CADWorks works with the BTL file. That works with the SPL file. We figured out how to map the two and do some concatenation with different attribute variables to make that process work. Here's our tables. They're 26 feet long. Sometimes we'll do a 28-footer, lean it or hang it off the end a little bit. They roll from one to the next. We frame on the first table, second curtain wall insulation on the second table and set windows. And then we strap, WRB and strap, and then stand up onto a trailer at the end. So those are the manufacturing constraints. So we have to incorporate those two. Length attribute, a little off screen there, but is the green lines. I have certain lengths. And I also am including balance when hoisting. That's where I'm going to make a break, is something we're thinking about, ease of installation. There's a lot to consider in where to make your vertical panel breaks. So taking all these kinds of constraints, and you start to schematize. That is a word I'm hot on, schema. It's so applicable. It's, essentially a structured framework that you can apply. There's a few other considerations. Well, I kind of went over most of these. Weight is another one I didn't talk about. Safety. These are all priorities and considerations that we are considering as we refine our constraints upstream in the design process. So one of the first things I started doing is making some just rough guidelines on what our parameters are for panelization. So designers, whether it be in-house or outside architect, we do a lot of custom work with outside architects. We have to get them to abide by our parameters. There's for wall and roof. These are flat stacked. So walls are shipping vertically, one against the other, forward or a rack. And then these we can stack 5, 6 high, our floor and roof panels. So let's revisit the historic process where we're bringing in all the sections and views. Now, I'm just going to get into the weeds a little here. This is specific to Revit, although I think it has implications on with other softwares for producing construction documents. I'm not promoting Revit's use. It's just what I have familiarity with. There's a lot of problems with it too. So anyways, all these sections and things in a plan, in Revit, there's a 3D model of it. So we already had a 3D representation in Revit, right? There's a rendering of it. In a plan set, if it's produced by Revit, this is the working methodology. Plan views and elevations and sections are actually slices of a 3D model. When you get into assembly details, it doesn't necessarily represent 3D. This is something always mysterious to me from a builder perspective that I'm sharing here with other builders, because your sections and things are going to be slices, but those assembly details where they don't work out, there's a good reason. They don't necessarily are informed by the geometry in the sections. Okay, so we're importing our slices, our plan views. We're bringing in our sections. And then this is the old process now. We're placing windows in manually, right? So all the walls and windows, that means finally created parametric tools. I generate the building, Takes a lot of work to get there. I had to dig through the window schedules. I had to cross-reference window mark numbers, reconcile with structural callouts. By the time you're getting into the weeds here, and then you fire something off to generate, and a header doesn't fit, and you have to undo. You go backwards. You adjust the rough volumes. Now I'm raising my panel height, or my L2 subfloor height. So now my elevations and my callouts on the plan section are invalidated. This is a common problem and very frustrating. It leads to, you're finding other things that are where the geometry doesn't match the architecture or the structural, especially the geometry not matching structural conditions is very, very common. So yeah, this is just to emphasize the frustrations involved in dealing with this stuff. And there's got to be a better way. Hey, so let's rethink it. We had that 3D model in Revit. If I could get the 3D from Revit to CAD work, there is a file format called Industry Foundation Classes, or IFC. You can import with IFC. It's an incredibly robust and interoperable schema that we have. I'm going to talk about it here for a bit. That I think we should all be looking at more closely as an industry. Industry Foundation Classes. Okay. It's an interoperable standard for architecture, engineering, construction. It's been around since the 90s, mid-90s, and it's actually like a consortium led by Autodesk. They formed this body, Building Smart International, and they said, we've got a problem here. We got all these softwares that are data siloed. Nothing's talking to one another. People are manually redrawing things or copying attribution data from one program to another. So they developed a standardization, a schema, an interoperable data standard called Industry Foundation Classes. It evolved from Exchange file semantic models. It made it into ISO standard in 2013, and it's still being updated all the time. In the past few years, it's seen a lot of expansion into defining bridges and roadways. It's being used in, $100 million, billion engineering projects in Asia and throughout Europe. United States as well. Here's a plug for a little documentary if anyone's interested in this. It's very interesting history. It's called The End of Babel. Just look it up on YouTube. It was produced in the 90s, around the time that the original IFC schema launched. It has one of those, I can't remember his name, James something, one of the BBC guys narrating. It's really great. IFC. Why again to the open and interoperable standard, and why I'm just going to talk about that for a minute. This format allows us to exchange data without restrictions imposed by proprietary formats. Again, it's actually an interoperable standard, and it has a lot of compatibility with all the big players in the AEC software. And yeah, so it lets you use the tools you want, and you can export it and then import it into another format. And yeah, it's software agnostic. It's a interoperable standard that we have, and it's for geometry. Sorry if I didn't really iterate that much, but it is for geometry, but as well as attribution. I'm going to talk here quickly about what it is. It's actually just a text file. Can be very long. It can be hundreds of thousands of lines, easy. And each line, it's in the step format, standard exchange protocol, technical exchange, I think. Each line has a UUID, like a unique hash, a number at the beginning, and then and it just basically builds relationships between the different line entries. It supports all kinds of geometries, solid modeling, splices, meshes, tessellated. You can do point clouds and things, and it has rich attribution data. And that's one thing I want to talk to you about. Getting back to BIM and DfMA is this is really a two-pronged approach, is how I've been explaining it to people: geometry and attribution, the two together. An analogy for you. This is something I've been honing in on. So websites, if you hit Control U in any web browser, you're going to get a view of the source of the HTML that underlies it, that describes, schematically describes the web page, it's rendered. In looking at IFC data, what we have is a source code for the built environment. So yes, it's like an HTML or a source code of the built environment. That's how I'm trying to explain it to people. Here's our new process where, we're using Revit currently, the designers in-house. So we're exporting IFC. I take the IFC data. I can manipulate it with a library called IFC OpenShell and a tool called, it was called Blender BIM, now it's called Bonsai, and then into CADWork. And I have an exact representation of the data that the plan set was created from. Here's an alternate I'm interested in, is this thing called Speckle. I don't know if anyone's using Speckle connectors in their workflows, but it's worth investigating. I can't use it. CADWork doesn't have compatibility, but I'm able to use it between Revit and Bonsai, which I'll talk about in a minute here. Yes, Bonsai, IFC OpenShell. Bonsai is a free, as in freedom. Anyone can download it for free, but also use it for any purpose, modify it, redistribute it in any way they want. And it's native IFC authoring. So instead of having like a siloed working in Revit and then converting and exporting to IFC, you're literally working directly in the IFC file. It's very, very cool. It's built on top of IFC OpenShell. I know I'm getting it technical here, but it is worth explaining. This is a great community. I hope everyone will check out who's interested. Is the open source Arch community, osarch.org. They have a discussion forum and a great wiki. Good place to start. Here's a look at Bonsai, Blender BIM, looking directly at IFC data. And again, with the attribution, you can get into things like scheduling and cost takeoffs, and it has some great GIS tools for importing OpenStreetMaps or Google Maps satellite data. Facilities management, drawings are coming. It's a work in progress, but there's a lot of possibilities with the software. So it sounds great. I'm selling it really hard. IFC as a interoperable exchange, and I went so far as like designing the whole business workflow around it, and just like, this is going to change everything. Well, let me tell you, it's in practice, it's pretty tough to use. It's very confusing, dense schema. In trying to make improvements to our process using it, it's been a very hard battle. But if you keep it simple and you, again, the two-pronged approach, geometry and attribution. Let's talk geometry. Geometry. So geometry targets. I created for our company internally a big packet full of geometry reference images. So this is, again, I'm not producing the CADWork model from the plan set anymore. So if they model in accordance to my geometry targets, I can just import those panels the rough volumes for the panels they've created. So honing in on things like floor to wall and wall to floor to roof intersections, things like that, giving them guidelines that they can design to and always conform to, greatly reduces the amount of complications downstream in producing panelization plan. So standardizing conditions. We did something, we took the gable wall. We said any gable wall where we have our air barrier detail wrapping, we use a gasket on the end of our eave wall panel, will turn the corner. So we say gables go all the way every time. So every gable panel, you can see here, this sort of, the eave wall is always butting to the gable. Always. And just standardizing things like that. Here's one of our roof some of our roof connection details. So, I take the structural and I sort of abstract it into just the rough volumes that we need modeled properly. And it starts to get you to, here's how, if we model just like this in the design process, when I get to do my generation, it's going to be a home run. There will be no surprises. It takes some work from the designers. Like there's in Revit families, and I imagine similar in other softwares, different kind of complications. Like Revit wants to just like glue things to the bottom, a wall to the bottom of a roof, like this here, for instance. That doesn't work well for what we want. I need to identify the spring point. Spring points are very important in modeling accurately. So that's an example. I want the break right there. So that was what it used to be. This is how we're modeling it now. Attribution, again, keeping it simple. Like this is a look at sort of the different IFC classes. IFC as a class for describing walls, roofs, floors are called slab, windows, openings, spaces. So as we progress from schematic design through design development, and at the end there, I have IFC column and beam. If I were in construction documents, if we have specific structural callouts, I like to have the designers model them, so the implications of that can arise from their introduction can be rectified. All modeled compliance with geometry, except for my slide. Okay. So this is just a slide I pulled from a talk by Helena Lidlow on prefab housing factories in Sweden. And I've annotated it with Revit CADWorks shop build. So it's sort of showing what it's showing. I like this slide because it's depicting as we move from left to right, the various stages: Revit, CADWorks, shop build, site install. It's the project knowledge and the digital information. You can see that sawtoothing. It drops off. This is very, very common in our industry, where people are manually redrawing things or copying info from one program into another. And if we can eliminate these humps here with BIM data and IFC, I think we'll have a lot of ground to gain there. So, and then in closing here, I have my horse, BIM in theory, BIM BIM plan for specific use cases, and BIM in practice. And that's it. Thank you very much. I know I finished a bit early. I have 10 minutes left on my clock. I'm happy to elaborate on anything anyone wants to hear, or you can open for questions.
Well, thanks, Alex. That was quite technical and quite awesome. And you can see your hero's journey throughout the process of going through those different schemas and frustrations with software. You've taken on quite a bit to improve there. But any great insights that you can give over the past 4 years that you guys have overcome in the shop? I mean, from where you started to where you guys are now?
Well, it's hard. It's very hard to one of the complications is we have a design pipeline, whether it be our internal designs or outside work from outside architects. So that's a frustration, is wanting to make improvements, but it taking, sometimes 8-10 months to see something implemented. And, just as much as we can come to standardizing some of these things, I think just throughout the industry, not just internal to our process, I'm very interested in sharing these processes openly in the thought that we can all avoid redrawing and minimize the amount of just mundane manual tasks that could be avoided with proper planning and like a higher level schematic design. But we're getting really good, actually. In the past year, we've seen a lot of improvements to our process, and it gives us a lot of flexibility. Um, in what we can execute on, like, quickly or accurately. Um, I didn't go into like what parameters per house design, but there are some interesting thoughts there around limiting the like a gable can continue to run out longer and longer, and we just add more panels, but yet the roof and floor geometry would all be recyclable from an old plan, or could be easily adapted. So for anyone looking at offsite or panelized construction, that's a real important consideration and constraint to set for yourself early on. Um, I think there is a lot of room for adaptability. You don't need to just be a cookie cutter plan again and again. You can still be pretty efficient at getting to a panel build with just staying in well-defined constraints. It doesn't have to be the same house over and over. But there are certain constraints that are really worth sticking to. Building width is a big one. And again, we're guilty of not abiding by that in the past many times, but we're getting better and better at it. Another thing I'll say is the annotation data, and or just attribution data, like in whether it be in Revit or in ArchiCAD, or Rhino, are all capable of exporting IFC data, and they all have some sort of internal interface for configuring map parameter mappings, like or like attribute mappings from internal to that specific program, and then you can apply or map the attributes in the internal siloed data structure to the industry foundation class format. And I'm really interested in standardizing that, more broadly across firms, not just internal to our operations, but can I send someone a .rvt Revit file that has some like guardrails set up for the geometry, as well as is populated with like a Revit family drawing kit that would be, when they drew something and exported the IFC, all those attributes would be mapped in a way that I would expect to see. It would be like, it's predictable. Predictability, repetition, for DfMA are paramount.
Can you explain what DSMA is?
DfMA, Design for Manufacturing and Assembly. Sorry.
Okay. All right. Great.
Yeah.
Do you have any questions, Mark? Let me see. Any
Hey,
questions?
Kevin, before we hop into there, I got two very smart people beside me that just want to say hello. They took a break out of the floor here at Greenbuild. Want to say hello to everybody. And of course, we were amazed by Alex, but they recently did a presentation together. So
Hi, Alex.
this is a bit old news for them,
Hey.
but amazing stuff. I mean, I love, before we get to Ed's question, I mean, there's that one slide there with the workflow. I definitely know that when this gets published, I'm going back in, screenshotting that, and going to work through your mind. I'm going to go to like the Matrix, get into your head and
Oh,
figure
yeah.
out how that all came together, because that was pretty intense. It's pretty awesome. I've done some similar
And
stuff.
I'm just going to pat that tired horse that came in right on the next slide, because I feel your pain, Alex.
Yeah.
Great presentation.
Thank you.
Yeah, I love the image of, the strong horse, and then the one you have here is like, the grade 2 pony. So I love it.
So it looks like a horse though still. So that's
it's
the important thing.
Yeah, it's got a tail and 4 legs. Yeah. Yeah, no, absolutely. Mark, did you have any comments? And if not, let's head over to Ed. Ed, I feel like it's one smart person talking to another smart person, and we're just going to stand back and enjoy your conversation.
Hey, Sean. Oh, no, I'm sorry. I didn't have any specific question. I just wanted to say, hey, and that I was really impressed. It's fantastic to see the work you're doing there, Alex, and really exciting. I didn't have any specific question though. Sorry.
Cool. Yeah. Did you see your cameo in the slides there?
No, I logged in
No.
a few minutes late. I think I missed that. Sorry.
Yeah, I took a screenshot of the PHA website, and you're
Oh,
featured on front. So no, it's
oh,
good to
gotcha.
meet you, Ed. Talk
Yeah,
to you.
yeah,
Yeah.
yeah. Good to talk to you in person too. I've certainly, we've corresponded a little bit. It seems great, the type of work you're doing there. I'm curious, I guess, to what Kevin was saying, where you've seen the biggest payoff from these types of workflow improvements. I mean, is it just in streamlining and improving profitability and reducing the number of hours? Like, where are you guys seeing the most improvement, or is it just like saving yourself the mental anguish of redrawing other people's models over and over and over and
Yeah,
over and
I'd
over
say
again?
that primarily. You know, I have another image I've used to sell this internally at the company. It was showing like a very similar house that was drawn manually each time. And just yeah, the anguish of doing something over,
Can I
just
actually,
repeating the same mistake.
I do have one question. I'm sorry to
Sure.
butt in. I'm curious about your thoughts. I mean, I don't know how to say this in the most diplomatic way. Would you actually take a model created by a client and just go build it? Like, would
Yeah.
you really do that, or would you,
It ha
as the guy
it
swinging the hammer, like, would
yeah.
you really want to be more in control than that? I'm just curious about your thoughts
Well,
on.
again, like something I didn't talk about here, but a really helpful framework for discussing like the clarity to which something is modeled, like from schematic design um, through the as-built, really, is the level of development LOD standard, 200, 300, 350, 400. And um, so where I am, I'm taking things from 300 to 400, which is like taking roughly placed volumes and windows and openings that are accurate and then creating the discrete geometry that goes inside them. But there's times where, especially with outside architect, where, you know, I'm still doing construction coordination or like design development work before I can do that. Like I'm not at LOD 300, which is what I'd like to receive things at. So, and again, just talking to the longevity of our project pipeline, and like, yes, I'm dealing with projects that were not optimized for our build parameters. And there's things we can do, like I'll break panels in weird ways and ship them on their side, or it gets very complicated. But in general, like in what I'm interested with uh, IFC, there's something called IDS. I don't remember what it stands for, but it's a build smart definition, and it basically is like it will um, check IFC data to make sure it conforms to a specification that is um, published by, that would be by us in this case, right? We'd say we need BIM data that conforms to this specification and is validated by this IDS tool. Again, that's a way long shot. That is years from happening, but getting that to be part of the conversation and on people's radar, I think is really important thing to be doing. And one other thing I want to just say that I didn't bring up in the talk, but just this idea of moving, and Ed and I have talked about this in email, just moving from like the construction documents as the deliverable to the BIM data, to the geometry and the attribution being very well defined and in specification with whoever's receiving, um, wherever it's going downstream. That is like a shift in how we work in this industry, and I think it's time has come. um, and yeah, I mean, architects, it means um, changing workflows, and that's another really difficult thing, and especially with design, you're just working in these limited parameters, and where's the architectural freedom then? And those are all real conversations to have. Um, so yeah, it's difficult, Ed. You know.
Yeah.
Yeah.
We're considered specifiers, and our details are supposed to be specific. And a lot of the details I look at that are going to be built are not very specific or detailed.
Right.
And that's the nerdiness of our game of being in Passive House, is identifying wall thicknesses and dimensions, and everything matters. All the little bits and pieces all add up. And I think it's great. I've learned so much from being a part of the accelerator and presentations that Ilka's done, and all the whole team at Holstrom. You know, it's been a new learning experience for me, and you guys are pushing the envelope up there in Maine. And, you know, I mean, East Coast wise, if you guys are New York City's in your or outer boroughs in New York City or in your range, I'm definitely going to be pushing for you guys for some of my projects that I can influence people to build more panelized. I love the movement of panelized construction. It does really reduce waste, and the product you guys are delivering of being certified Passive House with 14-inch walls, no heavy push, but an 8-inch, a 7-inch insulated wall. With you guys using cellulose, or you guys are using a wood fiber?
We're using both, actually. Yeah.
Awesome.
Yeah, our curtain wall, insulation wall is wood fiber right now, and then inboard of that is a structural wall surface cavity that gets cellulose on site.
Cool.
Yeah. Yeah,
Super.
and another thing, just the promise, you know, again, this is more the charging horse and promise of IFC, or what some of the things I'm seeing, and I really do encourage everyone to check out Bonsai, that Blender add-on for looking at IFC data, is things like carbon analysis and material takeoffs, like life cycle management, all of that. Again, if IFC can be seen as the source code of the built environment, that file, that IFC file, can live on with a building and can be used in doing. I mean, it is done in, like, you know, not so much in light construction. It's done in larger engineered projects, and institutional architecture projects will have an IFC, you know, that live, or some BIM data that lives on in the life cycle management phase. And I think just grabbing some of that stuff and bringing it into light construction and utilizing it could really, really move the needle on efficiency. So yeah, that's where Ed and I's conversation has been, is looking at investigating workflows for streamlining into Honeybee and PHPP from IFC data. Not really working yet, but I've got it block diagrammed.
Yeah, I guess I'm next here. I'm Patricia. I've been away from y'all about 4 years, and you've done huge things since then. So I'm just catching up. So just answer my question very simply. I have a lot to catch up on. I'm an architect, and I just use the basic. I use DataCAD, which is more for architects. It's a little bit simpler than trying to get into AutoCAD.
Mm-hmm.
And so I haven't used Revit or any of the other add-ons. And so my question is, do I need to get it Revit first before I can, what is my next step to looking into?
No, I definitely don't need Revit.
Okay.
You know,
What would the next step be for somebody that just uses CAD?
just using CAD in moving to 3D modeling, or
no, and moving to this, what you're talking
okay,
about.
sure. Well, if you know, if you were working with a specific manufacturer, asking them for guidelines on what they can build, and keeping all those considerations in mind when you're designing. I think, you know, even if you did that in just in CAD and 2D, and you had something where you were modeling, you know, your top of subfloor level 2 was
Yeah,
going to work with, you know, again,
I get that,
Yeah.
because I know the program I have has a lot more than I can use, but I
Yeah.
mean, what is the next step after to get into what you're doing?
I see. Well, I would look at, I would personally, I would be interested in looking at Bonsai and Blender BIM, and working natively with IFC data. I think this has so much promise. And again, the tools are being developed by community members right now. It's a free open source software project, and it has a long way to go. But people are doing like proof of concept work where they're producing sections and elevations and things from slices of IFC data, rendering out to SVG scalable vector graphic format, which it's analogous to a DXF, or you can open it and converts to PDF very easily. So producing construction documents from IFC data, I think, will be viable in the future. And again, the tools right now are more hacker friendly. And, like I hang out in a chat room and discuss bugs in the software. It's buggy and it's experimental, but increasing visibility to that project, I don't know. It makes so much sense to me. Rather than working in all these siloed data formats and using the IFC to just move data from one silo to another, let's just embrace it. It is clunky and messy, but I think it's definitely worth chasing down.
What was that FDG? You said it was
Oh,
like
SVG, scalable vector graphic, S.svg. Yeah. Yeah.
Thank you so much.
If you're interested in, I just reach out to me. I can talk your ear off about all this stuff. I'd be happy to at
Thank
length.
you so much.
Yeah.
Thank you.
Hey, Alex, let's pause for a second and send over to Zach for sponsors.
Yeah, great. Thanks, Alex. This is really amazing. Really appreciate your presentation today. I just want to take a moment to thank the fine organizations that make our work here at Passive House Accelerator possible, starting with our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you, too, to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwell North America, and Zola Windows. And thanks to our champion sponsors, Bewizo, Icon Windows and Doors, Intelligent Membranes, and Source 2050. And thanks to our patron sponsors, Brennan, Holstrom System, Inotech Windows and Doors, Lamelux, Longboard, RDH Building Science, and Sanderson Sustainable Design. Thank you, sponsors.
All right, and I've got a few of them here, which is pretty cool there, Zach. Let's head over to, I think we had Dale was next. Dale, still with us?
Audio, yes, I'm still with you. I've this greatly. I've knocked my computer over. That was really excellent, and I like what Ed May said. But at first, I was asking you to teach a class on this. But then I got into what Mario was saying about you're really looking at integrating software. And what it came to my mind is this is really basically what artificial intelligence is, because all artificial intelligence is DBase, which they renamed Access by Microsoft after they stole it, or did whatever they did. Now, are you putting all this together? What most of your architects, maybe what probably a lot of designers, is something that is similar to a plug and play where you can pull all this together, materials, the climate, and you've integrated different softwares. That's part of the challenge. Are you going to expand on this concept you're doing for your company? Because I think there's a lot of potential here to make designing and building more efficient. And if we're going to get the cost down and broaden the base of Passive House worldwide, we have to increase efficiencies. And doing the software is where you get one thing and maybe it brings up a question, well, you need to look at this. Not that you're trying to figure out how to make it play in that software, but it can integrate into the software and just bring you a list of questions or challenges that you have to now reanalyze, but have an idea of where to go.
Mm-hmm.
Hope that makes some sense.
Yeah. Well, with AI, I've seen some interesting demos recently. Again, that IFC manipulation, authoring, editing, merging toolkit called IFC OpenShell. It has a C++ library and a Python library. I've experimented quite a bit with the Python library, and can't remember the name of the Google Code tool, but it can totally it knows the IFC OpenShell library and how to use it. I've done some test like renaming or just querying of an IFC file using with AI, and it's needed a little massaging, but it works well. Yeah, I think there's a lot of potential for that. It really becomes a as it gets more capable, it just becomes like you become like an AI jockey. You just gotta know how to ask the right things and carefully word things for the prompts so you get the result you intend. It's kind of a interesting emerging field, I think, where people with little coding experience are becoming developers and using this method. But yeah, I in terms of like material libraries and thermal properties, like the EC is it EC3 or E3C carbon library. Um, like uh, being able to like query that stuff, like the data doesn't have to be directly embedded into the IFC file in terms of like pricing or thermal properties or densities or weight. It could be maybe weight, but other things could be queryable against an external database. And again, it's just like having more interoperability and opportunities for like everybody sort of using the same standard information. Very appealing.
All right, great. So who's up on the next question? Is it Justin's iPhone? Justin's iPhone, are you still here? If not, we can move on to Ian.
Yeah, I'm here. I actually work with Alex, and I thought maybe he could talk a little bit more about how attribution data makes it through our design pipeline and how we use it, since it's such an important part of our process.
Yes. Great. Great. Thank you for bringing that up. Thank you, Justin. Yeah. So, we have a schema for organizing a building. I've seen something similar sort of described as like a de-entanglement schema or like just way to break apart the building into various systems based on groupings or attributes. So we have like we do by story or like level 1, level 2. We do by wall type, exterior wall, interior wall. We have tons of attribution data. We err on the side of way too much. We can grab things by whether they're on layout or off layout, whether they're destined for our automated linear processing saw or not, where they're going on the shop floor. And like we have all that really dialed in CAD work, where we do a lot of the modeling for producing shop drawings and cut files and things. So what we've been doing is mapping that schema upstream back into Revit. So IFC has something called IFC story, and it works by default really in Revit. Amazingly, one of the few IFC mappings that actually is predictable. If you have a defined L2 horizontal in your Revit file, I'm sure it's similar in ArchiCAD as well. So now I have like I'm able to, when I bring in the IFC data into CAD work, I can grab it by the IFC attribute, which corresponds to story. Then I can map that story to wall type, exterior, and then with a script, attribute that to second story exterior wall, first floor exterior wall. So those mappings are becoming possible in our workflow right now. It's really cool. The other thing, like in Revit, you're just modeling a prismatic volume, like the layer, it's BIM data, so it knows about the layers of the wall assembly. It doesn't know about studs and things, or counts, but you can extrapolate that info based on just the way you would do a manual takeoff. This is getting off subject from how we map attributes, but trying to think another way we'd use it, Justin. Anything come to mind for you? Building type. We have a lot of buildings where we have house, garage, or shed. IFC at the top level. IFC is like a tree, a nested hierarchy. At the top is IFC site, and then IFC buildings are the classes underneath that. So we have type for house, an outbuilding, a porch, or like a breezeway connector. We have different building types for those. We're working on mapping. Yeah.
Love that phrase. Love how you guys are cataloging it and working on the language that works best for your guys' firm. And I'm sure how you use that language is going to get adopted by the teams that you work with, the consultants. So great stuff. These two have to go hit the floor because, again, there's great people to meet, especially our good friend Chris Magwood, who is here with RMI. We will be talking to him later, and we look forward to seeing him on December 6th. And we also have sponsors on the floor that we got to go see too, Rockwell Longboard. So it's great to see the accelerator is here in different formats, and the three of us are infiltrating all of our great contacts to enjoy what's happening here. So if you do need to leave, that's great. Hopefully you'll be back tomorrow to hang out with Mike Cairns from Intertech. I will hopefully pop in here too, because Mike is not only a great dancer, singer, but when it comes to Windows, he is the window geek. That's where you can find him on Instagram. And again, check out all the amazing things, but hopefully sign up for the Reimagine Collective. It is so cool to see the format, the things that are happening there behind the scenes, and just the daily stuff that's going on. It's a really cool opportunity to connect with people and join in. So then you get the freebies for all these amazing events that we're pumping out every month. So great work to Zach and the Accelerator team, and Kim as well. We will have kind of like the final 15. So if we got a couple more questions, we'll keep Alex, and then otherwise we got to go back to the show, and you guys got to go back to work, back to lunch, back to dinner, back to whatever's going on in your world.
Okay, great. Alex, that was an awesome presentation. I've got a question about how you're using Bonsai in your workflow. Is this like a visual text editor? Like, are you cleaning up attributes and stuff before you bring it into CAD work? Or can you kind of speak to how it's working as a buffer between Revit and CAD work?
Sure. Yeah. Great question. Yeah, I'm checking. I find it a lot easier to check. That's how I started using, just checking the output of IFC files. It has really good tools for, like, you can pick an attribute or a property and just like assign colors based on what that is. Or you can very quickly filter down. Like, it has much more granular control than the CAD work import tool like they have called BIM Manager, and you really just like can get IFC type filtering. More is possible with scripting, but as far as the graphical user interface goes, I've been using it to rename or tuck in attribute data that I have had trouble doing in Revit. If you're interested in some of the things I'm doing, definitely get in touch. I'd be happy to show you how I'm using it in my workflow. But I have used it for editing geometry as well. So it's a complicated tool to use because you have to use the IFC editing tools. You're able to draw in 3D directly in IFC. You're creating IFC data when you move, when you like extrude a volume. You're literally authoring IFC data, but you can also switch to the Blender internal modeling schema. I suppose it's like any other software where you have linked IFC data being, visible in the viewport, but you can also draw with the internal tools. So it's definitely taking a learning curve to be able to edit the geometry. But one thing that I got going that worked really well is we had models that were getting exported from Revit that was using a window family where I was getting like a Boolean, like a punch out through the wall, as opposed to an actual volume that represented the unit size. And I was able to create with IFC OpenShell through Bonsai, which at the time was called Blender BIM. It's only been a few months that they switched the name, but to create a bounding box around that geometry, and then delete the Boolean and keep like a volume that was represented the window unit size. So just coming up, and what I'm really interested in is takeoffs, QTO, and carbon and energy analysis and solar studies. Like all these things are possible in the near future using Bonsai. But that's a great question. Thank you for it. And if you're at all even a little bit interested, get in touch with me. I'd be happy to talk at length about it. Thank
Thanks,
you.
Alex. Yeah, I am working with both of those programs, so I'll probably send you an email.
Great.
Yeah, I guess I'm going to try to pivot. I'm going to try to take it because
Sure.
Dale asked my question. So aside of that, I'm going to try to bring it back more to the labor. This is all fantastic. I have no idea what you guys are talking about. I've mostly been doing just remodels. This is what I've been doing in construction, and I'm a laborer, so I don't do any of the design. I don't do any of the sales or anything. But I guess I'm going to sort of pivot my question more into like the technical. More into like the actual labor stuff, like how you've seen the company grow. Obviously, you guys put in a new building. I don't know if that was too recent or if it was some time ago. And how you guys are seeing the prefab growing maybe in the Northeast, the market itself. I don't know if you have access to understand what the plans of the company are, sort of how you guys project the market to go, at least in your area or en masse. How you've seen, if you've had access to clients, or if you realize like, oh, when we were looking at our project, we were looking at either prefab or we were looking at on-site. And obviously you guys are limited by weather, but here in Southern California, we're not really limited by weather. So I'm just kind of trying to understand,
Sure,
how many of the projects that you guys bid on are actually being sold as prefab. Like I said, I don't know if the numbers, I don't know if the client would tell, one of your project managers or whatever, oh, we reached out to 4 or 5 contractors and we decided to go with you. I don't know how that works. So I'm just trying to bring it more into a realm of what I understand as far as a laborer, as a, prospective builder.
Okay, great. So the shop, we opened our new shop last April. We moved in. We started building it a year and a half ago. In terms of like efficiencies on the shop floor, we've seen from this process, there's a lot, because as we standardize components and pieces of the assembly, the shop guys know what they're looking at, know what they're dealing with. They know, oh, this is our typical 3-pitch eave detail. Here it is again. Oh, here's our 10-pitch floor, 10-pitch roof to floor connection. And we just feedback from them comes up to me, which if it has implications further upstream, I can impart those. So that's all great in terms of getting more accurate and speed, which was in turn drives price down, right? In terms of what market, the pandemic was crazy for prices, and things are coming back down for sure. But our product became pretty expensive for a while there, and with all the efficiencies we can gain and again, just predictability and repetition of details, the price will come down. And what I see, we're still doing a lot of coastal homes that can be on the more expensive side. There's a lot of interest at our company and throughout the industry looking at multifamily and more efficient volumes just for multiple units, shared utility rooms. Ooh, that sounds nice. So I think seeing, especially with the need for housing we have, you know, in North America, globally, really, right now. I would like to see a future where, again, you could you could download a house. You could, it'll be a, you know, and this is actually being done. I've seen a few examples recently where like Revit files and IFC files were made available either by like a housing authority or just some people in the industry looking to make an impact and like jumpstart housing development, getting to certificate of occupancy. You know, traditionally in panelized assembly, that's going to be a long process. You're not going to be able to get there in 4 months or something, but from closing financing. But I do think it's possible. So that's where I'm interested in just continuing to fine tune the efficiencies, and also, like I was saying, just speak a broader language. Like other people, other firms, other panelized companies, other designers know there's a shared sort of schema or just a language to speak in around parameterization of details for design for manufacturing. Yeah. So yeah, there's volumetric modules, you're stacking boxes, and there's panelized. We
And
like
Alex, too,
panelized. Yeah.
yeah, and even in the panelized world, you know, the fact that you're seeing panelized growing because you now are putting insulation and your membranes and wrapping it all together and having those three components, and that's where there's exciting growth happening in your business model, because then people are getting, you know, a high performing home because you're getting three products in one,
Yeah.
not just the regular truss companies just shipping out panels. Which
Right.
I was in your neighborhood and I definitely saw a lot of wall panels going down the road with no insulation. I was like,
Sure.
ah, it looks so nice, yet bit of a waste, missed opportunity.
Yeah.
Right.
Yeah, sure.
But
Yeah.
that's the best part of the growth is, you know, and Mary, even in your neck of the woods, you know, the stuff happening with B Public Prefab in, you know, New Mexico, and the growth of other companies in the West, you know, up in the West Coast. There's
Yeah.
there's lots of opportunity. So
There's a couple there. I think there's one out here in Bakersfield. I did pass by B Public. I didn't drive into Las Vegas, but I was
Next time,
driving
stop
driving to
in.
Chicago, so I just drove past it.
Yeah. No, all good. No, there's lots of opportunities, Mary. That's great.